Okay, so on lesson 50, number 15 and 16, you are going to be writing the equation of a sinusoid. And so to do that, I want to go back and look at what a regular sine function looks like and what a regular cosine function looks like. Okay, a regular sine function is going to look like this, because if you look at your unit circle, if you don't have your unit circle out, you might want to pause this and get it out. You'll notice that when you are at 0 degrees or 0 radians, sine has a value of 0. So that's why this graph goes through 0, 0, because when the angle is 0, its sine is 0. And then we know that once we get up to 90 degrees, so pi over 2 or 90 degrees, we know that sine has a value of 1. So that's why this curve goes up to the 1. It goes right through the origin and then goes up to 1. And then once we get to 180 or pi degrees or radians, we're back down to 0. And then when we get to 3 pi over 2, which is 270 degrees, we're back down to -1. And then once we complete the circle, we're back to 0 again. So this is what the sine graph looks like. It starts out at 0, 0, goes up to 1, down, and so on. All right. The cosine function looks exactly like it, except it's shifted, because the cosine, when you're at 0 degrees, is at 1. Okay, because at 0 degrees, the point on your unit circle is 1, 0, and the cosine is the x-coordinate, which is 1. All right. When you get to 90 degrees, or pi over 2, cosine is 0. When you get down to -1, when you get to pi, that's 180 degrees, cosine is at -1. So this is what a cosine function looks like. All right. So the two things you need to remember first when you're looking at problems like let's see, 15 and 16, is that you need to look first of all where this graph starts at when it's at the origin. When you're here, is it going through the origin like this? Or is it starting out at the top of the hill, which is what cosine does? All right, so this is going to be a cosine graph. We're going to want to graph it as a cosine because it starts at the top of the hill instead of starting by going through the origin, which is really not the origin on this one, because this dotted line here is not the x-axis, it's 5. We can see that this graph is not only a cosine graph, but it's also been shifted up 5 units. All right, because usually when you're dealing with your regular cosine graph, let me find it. When you're looking at a regular cosine graph, of course, this is just the x-axis. It's just 0. But the picture on number 15 is of a graph that's been shifted up 5 units, because we can see that our horizontal axis is 5 instead of, sorry, let me find it again. Oops. All right, I'm going to find it. Maybe not. Okay, there it is. All right, so you can see that the horizontal line that's going straight through the middle of this is 5. So this whole graph has been shifted up 5. And then also you can see that on a regular cosine graph, the amplitude, that is the distance between the horizontal axis and the top of the hill, is usually just 1. But now you're going all the way from 5 up to 30. So that amplitude there, amplitude, is now 25, because you're going from 5 all the way up to 30. And also you're going down from 5 all the way down to -20, which is again 25 units. All right, so this graph has been scooted up 5 units, it's been translated up 5 units, and the amplitude has been stretched to 25. Everything else about it looks just like the regular cosine graph. So we have to change the equation from y equals cosine x to indicate what's happened to it. All right, so y equals cosine x is what this would have been, all right, or cosine theta in this case, there's an x here, so we're going to say x instead of theta. But now we have to add to the whole function, we have to add 5 because the whole thing's been scooted up 5. And remember our rules for moving functions around, that if you move something vertically up, that means you're going to subtract that amount from y. So y minus 5 is what happens when you take a graph and move it up 5. That's the rule we learned. And then also, this amplitude has been stretched now so that it's 25. So that means you're going to multiply the cosine function by 25. You're going to put a 25 here as the coefficient of cosine. All right, so that'll go there. So that's where the amplitude goes. And then you rewrite it so that y is by itself because function notation says y equals something. So y equals 5 plus 25 cosine x is the equation of this graph because it has been moved up 5 vertically, 5 units up, and then also the amplitude is now 25 instead of 1. So you are multiplying the cosine function by 25. All right, so the sine function, number 16, this is, well, this isn't a sine function. It's actually a cosine function too, because you can see that, again, it's not going through the origin. It's not going through, it's not crossing the horizontal axis when x is 0. So that's not a sine function. It's going to be, we're going to write it as a cosine function. So that's the first thing you look at when you do this, is if it goes right through here, either going up or going down, then you're going to write it as a sine function. But if it doesn't, if it's either at the top of the hill or the bottom of the hill when you start out at 0, when x is 0, then you're going to write it as a cosine function. So this starts at the bottom of the hill down here. So it's going to be a negative cosine function. If it starts at the top of the hill like this one, top of the hill up here, then it's a positive cosine function. If it starts at the bottom of the hill when x is 0, then it is a negative cosine function. So this is going to be y equals negative cosine theta. We're using theta this time because that's what they're doing. All right, but some things have changed. The horizontal axis is now 15, so this whole thing has been moved up 15. So again, we would subtract 15 from y, which in the end makes us add 15 to the other side. That's what happens when you move up vertically. That means you subtract that amount from y or add it to the other side of the equation. All right, and then the amplitude, if the horizontal axis is 15 and you're going all the way up to 40, then again, that amplitude is 25. 15 up to 40 is 25, and 15 down to negative 10 is 25 units. So the coefficient on cosine is going to be 25. I got to move that negative out of the way so that I can fit it in there. But it's going to be negative 25 cosine theta. So that is going to be the equation for that one.